In today's video, we're asking, should you use cross-site scripting filters on passwords? So first things first, what is a cross-site scripting filter? A cross-site scripting filter prevents users injecting a malicious payload into web pages by stripping and/or replacing characters which facilitate this kind of attack. Never ever trust anything a user enters. Always assume it's potentially harmful and could pose a risk to your application or others. So why are passwords different? Well, let's think about the context of an XSS filter for a moment. Its purpose is simply to sanitize a piece of data to ensure it's safe to output to the screen. But you should never need or indeed be able to display the user's password anywhere, let alone on the screen. Let's assume you're handling passwords safely, by which I mean securely hashing, generating a cryptographically secure pseudo-random number, key stretching, and utilizing either a hash-based message authentication code or encrypting the hash using something like AES. Now, it would be impossible for you to display the actual password on the screen, and if you're not displaying it on the screen or embedding it in the document object model, you don't need a cross-site scripting filter. But what about SQL injection? Again, assuming you're handling passwords safely, you don't need SQL or indeed any form of escaping either. Consider the following example, and for the sake of brevity, we'll ignore the variations across different programming languages. Step 1. Get the password from the request. Do not run a cross-site scripting filter on the field. If you use global cross-site scripting filtering, create an exception for all password fields across your entire application. Step 2. Validate it. Does it meet your requirements? Consider a minimum length, but never a maximum length. Is it of sufficient strength? Does it contain upper and lowercase alphanumerics, non-alphanumerics, and numbers? Step 3. Generate a cryptographically secure pseudo-random number and throw both the salt and the password, regardless of their content, to a sufficiently strong hashing algorithm. Now, both hash-based message authentication codes using SHA-256 via password-based key derivation function or bcrypt are both considered safe as of March 2013. The output hash can't contain any values which would allow an SQL injection attack, and if it can't contain any values, you don't need to escape it. Now, bear in mind, most frameworks use prepared or bind queries, which often escape the values automatically, so it won't affect your digest in any way, but just be mindful of the fact that the password can't contain anything damaging, providing you're hashing it correctly to begin with. So what if you already cross-site scripting filter your passwords? Well, unfortunately, most users use dictionary-based passwords, so this problem rarely comes to light until someone tries a more secure password combination. So consider the following example. Step 1. Get the password from the request, and in this case, let's imagine it's my pass greater than word separated with underscores. Step 2. Run it through your basic cross-site scripting filter. Now, in this case, we're just going to encode the HTML entities, so a greater than symbol becomes &GT semicolon. Now, because your password contains a greater than symbol, instead of hashing the original password, you're now hashing my pass &GT semicolon word separated with underscores. So you've just broken the hash. Now, that's fine if your cross-site scripting filter never changes, but if it does, your users can't log in. So how do you fix it? Well, the quickest option is to reset all of your passwords after you've updated your authentication process. Now, you can't look in the database to see if this has already occurred because your passwords are already hashed. But the next best option is a little bit more tricky. You need to alter your authentication process so new registrations and logins don't cross-site scripting filter your password fields, but doing so instantly breaks existing hashes that contain encoded values. So the next time a user logs in, create two variables. One is their password, exactly as it was entered. The other is a cross-site scripting filtered version. Compare the two. If they match, you know your mistake didn't affect that user. If they don't match, pass the filtered version to your query, and if it's correct, update the record with the non-filtered password. This method allows both existing and new users to log in. Any broken hashes are automatically fixed the next time the user logs in. If you record the date of each login, you can safely remove that extra logic from your module once the user's updated their password. So in conclusion, many developers add cross-site scripting filters to their passwords in the mistaken belief that it makes the system more secure. Do not, under any circumstances, apply XSS filtering to passwords. You're either going to break the hash or make the resulting hash far weaker.